if we didn't have that function over there, we could use our formulas, but our voltage source is given by a function. Now, it's not a very interesting function, but it's 2 unit step functions. So it's like you turn a switch at time t equals 0, and then you do another one. You turn it off at time t equals 3. This is equivalent to saying that we have the voltage at t equals 0 becomes 5, and then at 3 seconds it goes off. So that's what this is saying. So, but let's transform this to the S domain. And so when we do that, we take the Laplace transforms of our voltage and the Laplace transform of the voltage. So the Laplace transform of the unit step function is 1 over S. And the Laplace transform of the translated unit step function, so the Laplace transform of u of t minus t, is e to the minus ts over s. So you would need to know those. And so that gives us that this, when we take the Laplace transform of it, becomes 5 over s minus 5 over s e to the minus 3t.
Wait, e to the minus 3t?
Yes.
Minus 3s?
S. S. The resistor stays a resistor. The inductor becomes LS. L is just 1, so this is S. The capacitor becomes, I changed my mind for those who left. I want this to be 1/3 F. The capacitor becomes 1 over S times C. So this becomes 1 over S times 1/3. So that's 6. This is S. And this is 3 over S. I didn't tell you what we're looking for. We are looking for IL of t. Okay, so now, because we're in the S domain, we can treat all of this like a resistor, and we can say that V equals IR, or our voltage source, 5 over S minus 5 over S e to the minus 3s equals I times, these are all in series, so I can just add them together, 6 plus S plus 3 over S. So I can solve for I. I'm going to write this as 5 minus 5e to the negative 3s over s over 6 plus s plus 3 over s. Then I'm going to multiply this side by s over s. and I get 5 minus 5e to the negative 3s equals 6s plus s squared plus 3. Or this is the same as 5 over s squared, or 5 minus 5 I'm just changing the order here. S squared plus 6s plus 3, which is the same as 5 over s squared plus 6s plus 3 plus negative 5e to the negative 3s over s squared plus 6s plus 3. Okay, so now I would like to take the inverse Laplace transform, but to do that, I would need to factor these, and they're not complex, but they don't factor nicely, so I can still find their roots by using the quadratic formula. So I'm going to do polynomial solve, and let's see, a is 1 and b is 6. Was b 6?
Yes.
And c is 3. And I get x1 was minus 0.55 and x2 is minus 5.45. So this is 5 over s plus 0.55. Oh, wow. Okay. I could not ask for worse numbers with my s's and 5's looking, the same. Times s plus 5.45. So this first thing here is an s. Plus negative 5e to the minus 3s over s plus 0.55 and s plus 5.45. Then you would theoretically do partial fractions. So this is equal to a over s plus 0.55 plus b over s plus 5.45. Notice this is the same, it just has an e in it. So plus, or it'd actually be minus a e to the minus 3s over s plus 0.55 plus minus b over s plus 5.45. Bye. Okay, so y'all know how to do the partial fractions, right?
Yes.
Yeah. So when you do that and you solve for that, you get 1.02 for A and minus 1.02 for B.
So you,
This should also have an E on it.
I'm not complaining, 'cause this is good practice, but for on the test, do you think she's gonna give us something with E to the whatever?
No, it's what I had.
Okay, alright.
Yeah.
'Cause I'm.
No, I don't. But it's actually a real easy. It's on the chart. You just
Okay,
yeah.
'cause I just know
There's
I'm
nothing.
messing up,
There's
that's all.
yeah. It's so no. I don't think she would. I think it would just be this first part.
Because I'm not good at partial fraction decomp when it's like not very simple.
Yeah. So, but these are both. These are right here. So if we go and look, you can see that if you have 1 over s plus a, that's e to the minus at, and if you have e up there, then it just translates it a little bit. You just have the minus. So rather than having e to the minus at, we have e to the minus a t minus t.
Okay.
So what we get is this is 1.02 e to the minus 0.55 t minus 1.02 e to the minus 5.54 t minus 5 no, there's no 5 there. This is 1.02 minus 1.02 e to the minus 0.554 t minus 3, and that 3 is just coming from that, plus 1.02 e to the minus 5.45 t minus 3.
Just for a little look to the future, will we be doing stuff like this in circuits too?
You'll do stuff like this maybe in signals and systems, not in circuits.
Right.
Circuits too, no, I don't think so. But you would be doing it in signals.
Circuits too would be more imaginary numbers.
You're gonna have lots of imaginary numbers in circuits
yeah,
too,
I'm not good at those, but I'll
and
figure it out.
also in power.
Do you cover circuits too or no?
There is an SI for circuits too. It's not me. I have offered to do it before, and I actually think I might re-offer to do that. I wanted to do it because I wanted to go back and review circuits. This is not. I think this time that was our current. Yep, that was our current. So we are done with this one. So that is that one.